Hello, students. I miss you guys, and I hope you find this helpful. I'm going to do both problems from problem 8.5 in chapter 8, just walking you through the process of graphing sinusoidal functions, or as we call them in the past, trig functions or periodic functions. The first problem, letter A, is this equation that is y equals 3 cosine of the quantity pi times the quantity x plus 1 minus 2. And the thing that's probably drawing your attention the most is this variable here having pi in your equation, but don't worry, we'll figure it out. So my strategy for solving these is always to pick out the a, b, h, and k values first. So if I'm looking at this problem and I'm looking for a, I see it here at 3. If I'm looking for my b value, I see it here. It's going to be pi. If I'm looking for my h value, it's in here, and in parentheses means opposite direction, so it's actually going to move the graph left one space. And then my k value is this last part here, and that's -2. Now, hopefully you're thinking that we need one more piece of information to solve this, and you're right. The piece of information that we need is to find the period, and if I was doing this correctly, I would have used a different color because it actually relates to the b value of pi, right? And if we keep this in mind, that PB always equals 2 pi, then we can use that equation to figure out our period. So if B is pi, then we'd have P times pi equals 2 pi. So I just substituted pi in for B. And then to figure out what the period is, I'm going to divide by pi on both sides, which, as you can see, cancels out the pi with the giant 1 there, cancels out the pi with the giant 1 there. We're left with the period is equal to 2. And so that is different than a lot of problems we've seen in the past with these, where we don't have pi in the length of a cycle, but I'll show you how that works on the next screen here. Okay, so we found all of these parameters for this equation, and now we just want to get it onto a graph. So the first place that I start is with the k value, because that is essentially our midline. It is our midline. And so if we go down to -2, we know that the middle of our graph is going to be here. And then the next thing that we want to look for, hopefully you know this, is how high and how low the graph is going to go. And we're going to see that in the a value, which is here. And so that 3 tells us it's going to go 3 above the midline. So it's going to go this high, and it's going to go 3 below the midline, so down to -5. Here when we go -1, 0, 1, this is at 2. Okay. So our graph is going to happen between those dashed lines, with the -2 being the middle of the graph. So where 0 used to be, now it's -2. Okay, the next thing that we want to consider is that the length of one cycle, let's see, I'm going to pick a color here. I think I'm going to graph this using the darkest color. So the length of one cycle is the period, which means that a complete cycle of cosine happens in 2 units. And so if we were to start cosine at 0, then we would end the cycle at 2. So I'm going to mark my x-axis just by 1s. And we also know that we have a shift in this graph, that the whole graph is going to shift 1, or left 1. So we're not actually going to start at 0, we're going to start at -1. And so if the whole cycle is going to be 2 units long, it's going to start at -1. Sorry, not at that point, because cosine starts at the high point, right? So it's going to start here. I'm just going to erase this because I don't want to mislead anybody. Okay, so we're going to start at the -1 at the high point, and cosine always ends at a high point also. So 2 units later from -1, here's -1, 0 at 1, we're going to hit that high point again. And then half of 2 is 1. So if we go 1 unit away, that's going to be the low point down here, way down at -5. And then we have the points in the middle. So we want to mark our x-axis with those middle points as well. So if we split 1 in half, then we have 0.5s, right? So we have 0.5, 1.5, 2.5, and so on. On the other side, we have -0.5. Sorry, my pen doesn't write very well. So to fill in the rest of the cycle, we have our middle values between the 1s at the midline. So the cosine crosses the midline here and here. So that is one complete cycle of cosine. If we wanted to do another one, we'd go 2 units from 1 to 3, split that in half. That's going to be at 2, and split between 1 and 2.5. So we're going to get the midpoints here. So here's our second cycle of cosine. And remember to add your arrows to be precise. Okay, so that is 8.5a. And then if you want to keep watching, I will do the second problem also, which is 8.5b. And that's a problem that looks like this. Y equals 2 sine the quantity 1/3 times x minus pi over 2. Again, I start by listing the a, b, h, and k values. So let's start with a. 2, b, 1/3. Let's see, I haven't used blue yet. The h value is negative, so that means we're actually going to go to the right. Pi over 2 units. And the k value, there is none, so it's 0. There is no shift in the midline. And then remember that we also need to find the p, or the period, or the length of the cycle. And we find that by using the equation PB equals 2 pi. So we know the b value is 1/3. So we have p times 1/3 equals 2 pi, which means we need to divide by 1/3 and divide here by 1/3. Now, when we're dividing by a fraction, we use the reciprocal, right, and multiply. So 2 pi times 3/1. We can put this over 1. 2 pi times 3 is 6 pi over 1. Doesn't change it at all. So our period is 6 pi. And then we just want to graph that. So starting again always with the midline, which in this case we see is 0. So we don't have to shift our midline at all. We're going to keep the x-axis as our midline. And then going to the amplitude, which we see is 2. So we're going to go up 2 from 0, and we're going to go down 2 from 0. So our graph is going to be between 2 and -2. And then we want to think about a period being 6 pi. That means that we are going to have a complete cycle in 6 pi. So if I'm going to graph 2 cycles, I'm going to leave myself a little bit of room here. Let's say this is 6 pi. And then if I'm shifting it right, pi over 2, that means I need to have 3, 4, 5. Here's 1 and 2. So I have 1 pi, 2 pi, 3 pi. I'm not labeling everything because it's going to get really messy. 4 pi, 5 pi, 6 pi. And we're going to do half a pi shift. So that means we also need the little half marks in here. So half a pi is going to be marked on our axis. Okay, and then if we did that again, I'm going to extend this line out to have it at 12 pi. Split that in half, gives us 9 pi. There's 7 and 8, 10 and 11, and then the half marks between those. Sorry, this gets a little bit messy, but what we're scaling our x-axis by is pi over 2. Okay. If we did not have a shift, we'd start our sine graph at 0, and then we'd go to 6 pi. Since we have a shift here of pi over 2 to the right, we're going to shift it pi over 2. So we're going to start it here, and we're going to shift it pi over 2 past 6 pi. So we're going to end it here. And remember, the sine graph starts and ends at the midline, right? So then we're going to go halfway between these, which would normally be 3 pi. We're going to shift that pi over 2 to the right. So this is going to be the middle of our graph. Those are our 3 x-intercepts. And then sine goes up first. So halfway between 0 and 3 pi is 1.5 pi, which would be, I didn't scale this very well. It would be here. And then we're going to shift that pi over 2 to the right, so it's going to be at 2 pi up here. And then 3 and 6, halfway between that would normally be 4.5, but we're going to shift it half pi, so it's going to be at 5. So the low point's going to be here. So our graph looks like this. I could keep this going. The next cycle would end here, just 1 mark past 12 pi. Whoops, I don't know how I did that. Oh, there we go. And I could do those marks again. So basically, what I was doing is saying the whole graph is between 0 to 6 pi. Cut that in half for a midpoint of 3 pi. Cut that in half for the midpoints of 1.5 pi, but then because of the h shift, this actually becomes 3.5 pi, and this would actually become 2 pi on the graph. Whoa, I'm messing too close to the corner down here, and I keep changing the screen. So anyway, (1.5 pi shifted 0.5 to the right would be 2 pi. So 12 pi instead of 9 pi it would be 9.5 pi. It's going to hit up here in the middle. My second one isn't quite as accurate, but you see it would look something like that. As always, if you have questions, just email me, or I can go through this in person with you over Zoom. Hope you're doing well. Take care.